Hi, this is Adil. Today's topic is chemical bonding. Very important topic in Cambridge, and usually question comes from this topic. Chemical bonding, as the name says, it relates with chemicals and their composition and their bonding, how they relate. Say linked with each other. Now, when we start chemistry, we encounter with the periodic table, which is the list of all the elements that we have up till now that are being discovered. Now, around 103 or 105 elements have been discovered up till now. And these are the elements that are given in this periodic table. Now, my question or the question comes in the mind that are these the only chemicals that we have around us or that we use in our daily life? Obviously, no. There are thousands of chemicals around us, surrounding us. So, from where those chemicals come? Those chemicals that we encounter in our daily life are actually a different combination of these elements which are given in this periodic table. Now, you might would have completed this topic of periodic tables, so you would have know very well. You know very well that extreme left hand side are the metals, and the extreme right hand side are the non-metals, and the right hand side are the non-metals, and the extreme right hand side is the noble gases. Now, noble gases. Why they're noble gases? Why we call them noble gases? Because these elements or these gases, they occur as a single atom. Normally when we say gases, what comes to mind? That is a diatomic molecule, like hydrogen gas H2, nitrogen gas N2, chlorine gas Cl2. But these gases are really strange. They are not He2, not Ne2, not Ar2 or 3. They are just helium, neon, Ne, argon, Ar, krypton, Kr, xenon, X, and radon, Rn. So these are the gases that are composed only of a single atom. They don't need to combine with anyone else. They have completely outermost shell. So that's why we call them noble gases. Because they are noble, they don't need to meet with anyone, they don't need to combine with anyone. On the other hand, when we discuss about other elements and other chemical compounds, we find that they are in different composition. Either they are a group of 2 or 3 or 4, like oxygen O2 but water H2O, right? 3 atoms, 2 of oxygen, 1 of hydrogen, sulfuric acid H2SO4. So different chemicals, different combinations, and different number of atoms used in one molecule. Now, chemicals around us are present in different states as well as in different forms. They are either in form of element, pure element, simplest, purest elements, or they are in form of compounds. They can be small compounds, or there can be giant molecular structures, or giant ionic structures, or giant metallic structures. So all these elements, when they're combined in different ratios or when they're combined chemically, they give us compounds. 2 or more elements combining chemically in different ratios. These compounds can be ionic, can be covalent, can be coordinate covalent or dative bonding, what you call, or can be metallic. Now, when I say ionic combination, covalent combination, or metallic combination, this means this is actually the type of bonding. When we say ionic, it means ionic bonding, that is atoms are first, they will transform or convert into ions, and then those ions will combine to form an ionic compound, covalent compound, and so metallic compounds. Now, what are those parameters? What are those features? What are those grounds on which the bonding takes place? This is very important. As you know, that whole chemistry is revolving on a pivotal point, and that is electron. The number of electrons present in the outermost shell will determine the characteristic of that particular element. Whether it will fall in the metal category, non-metal category, it will come into the transition metal category, it will come into the gases, it will come to the solids, it will come to very strong reactive substance or very weak reactive substance. So everything based, the whole chemistry actually has a pivotal point, which is the number of electrons in the outermost shell. And the configuration of the outermost shell will tell you that what type of bonding gonna take place. So let's see. We are, in this picture, we have different atoms of different elements are shown. For example, hydrogen, carbon, nitrogen, oxygen. Hydrogen, what are the maximum number of electrons that can be filled in the first shell? Obviously 2. But we see that in hydrogen there is only 1 electron in the outermost shell. So how many it requires to complete the outermost shell? 1. Yeah. So it means it is incomplete, no? When it is incomplete, so to make the outer shell complete, it will combine with someone else so that it can gain 1 electron. Now that combination can be ionic or covalent. We'll see later. Now go to the carbon. Outermost shell 4 electrons, and this is second shell, mind it. So in the second shell there should be maximum 8 electrons. So 4 are missing in the outermost shell, so it needs 4 more. Same is goes with nitrogen. Outermost 5 electrons, 3 are missing, so it needs 3 more. Oxygen, outermost 6 electrons, 2 missing, so it means 2 more. So that deficiency of number of electrons will give rise to the concept of bonding. That is, elements will combine with each other to fill their outermost shell with complete number of electrons as per the designed shell, designated shell. Well, noble gases, on the other hand, they have their complete outermost shell. As I just said, they are noble. They don't need to combine with anyone. Say helium, only 1 shell, and that has only complete 2 electrons. Neon, outermost shell is filled with 8. Argon, outermost shell is filled with 8. So they don't need to combine with anyone. That's why we call them noble or zero group. Their valence state is 0. They don't need to combine. But rest of every element in the periodic table has a tendency to combine with someone else to make it outermost shell complete. And that is the base of that is the basic principle of bonding. So let's start with the ionic bonding. Now we just see that atoms without full, we discuss all that thingy. Now let's go to the ionic bonding. Always remember that ionic bonding takes place between the metals and the non-metals. That is between the group 1 and 2, group 1 and 6 and 7, or 2 and 6 and 7. This is the major or most common combination of ionic compounds. Group 1, talk about group 1. What is the valence state of group 1? What is the oxidation state of group 1? Or what is the group number of group 1? 1, obviously. So it means they have outermost shell containing only 1 electron. How many do they need to complete the outermost shell? 7. Oh, quite a big number. Electrons are very, very, very much precious thing in chemistry. They're like diamonds. So who will give them 7 diamonds to complete their 8 diamonds? Obviously no one. So what they do? They do a sacrifice. They give their 1 electron or the 2 electron from the second group to some other elements which has a deficiency of 1 or 2. Now when you give in your real life, when you give something, when you give an object to another person who needs that object, say like he's dying for that object, for example, because it's a very precious thingy. So if you give 1 diamond as a gift to someone else, what the other guy will treat, how he will treat with you? Will he make a bond with you, a bond of affection, a bond of love, a bond of friendship or not? Obviously. So same is true with the elements. So take the example of sodium and chlorine. The most common example everyone knows, sodium chloride. Sodium has how many electrons in the outermost shell? 1 electron. Chlorine has outermost shell filled with 7 electrons. Chlorine needs 1 electron to complete its outermost state. Sodium has only 1 electron, it needs 7. So obviously no one can give him 7. So what sodium will do? Sodium will lose, will donate. It's better to say donate. Sodium will donate its 1 electron to chlorine to make the outermost shell complete. So that electron which is being donated, we call it as transfer of electron from metal to non-metal. The atom that donates electron, or technically loses electron, becomes a positive ion, and the atom that is gaining that electron becomes a negative ion. And in that scenario, when the metal loses one electron, then the lower shell is now filled with 8, so it acquires a noble gas structure. Non-metal which had one deficiency of 1 or 2 electrons, when it gains those 1 or 2 electrons, its outermost shell is filled, so it means it also acquires the noble gas structure. Now upon gaining and losing, the atoms becomes ions. The one that loses electron becomes positive ion, we call it cations, and the one that gains electron becomes a negative ion, we call it anion. Now being oppositely charged, since there is electrostatic force between them, so they attract each other. So these ions, the positive and negative, are attracted towards each other to form a compound we call ionic compound, and the linkage between them, which is the pure electrostatic linkage, and we call it ionic linkage or ionic bond. Is it okay? Great. So let's do in depth. As I just said, we will discuss about sodium chloride. Okay, so sodium outermost shell 1. Configuration is 281. First shell 2 electrons, then 8 electrons, then 1 electrons. Chlorine on the other hand has a structure of 287. Now what will happen? Who will donate? Who is generous? Obviously sodium. Being a metal, sodium will donate or transfer its electron to chlorine. The 1 electron from sodium will be transferred to chlorine, giving a complete structure for chlorine and a complete empty structure for sodium. That empty structure will be discarded. So we jump to the lower structure now, which is filled with 8 electrons. Now since sodium has donated 1 electron, so it will get a positive charge. Chlorine has gained 1 electron, so it will get a negative charge. Now these two are no more atoms now, they are ions. So left hand side is positive ion, so cation. Right hand side negative ion, so anion. Being oppositely charged, there is an electrostatic force between them that will cause their attraction, because opposite always attract. So sodium and chlorine will attract each other, make a bond, and that bond is called ionic bond, and so we'll get a compound which is called sodium chloride. The second example, calcium chloride. If I ask you what is the formula for calcium chloride, you will say CaCl2. What the formula says? That 2 atoms of chlorine and 1 atom of calcium. Yeah, that's the case. Let's see. Calcium is in group 2, so its outermost shell contains 2 electrons. Chlorine in group 7, so it contains 7 electrons. Now calcium has 2 outermost electrons, so it needs 6. As I just said, electrons are like diamonds. Who will give 6 diamonds to calcium? No one. So what calcium will do? Being a generous person, being a generous element, it will donate. It will transfer its 2 electrons, one to one chlorine atom and the other to the second chlorine atom. So each chlorine atom, upon receiving an electron, will become a negative ion. You see here? Great. Since the outermost shell of calcium is now discarded, so the lower shell will come up with complete 8 electrons. So calcium will acquire a +2 charge. Oh, why +2? Because it lost 2 electrons, it donated 2 electrons, it transferred 2 electrons. Great. So it becomes a positive ion or cation. Chlorine, on the other hand, has gained 1 electron, so it becomes a chloride ion or an anion. Now since they are oppositely charged, and I just said that opposites always attract, so what will happen? They will attract towards each other. So each chlorine will make an electronic linkage or an ionic linkage with calcium, making CaCl2. Alright, is it clear? Great. So this is the way how these elements are formed. Same is true with the magnesium oxide, MgO. There's a formula. Now the formula says MgO. It means each is sharing the equal number. I mean, say like, Mg is outermost 2 electrons. Oxygen needs 2 electrons. So 2 are being shifted over there. Mg will gain 2 positive charge. Oxygen will gain 2 negative charge. Since the charges are same, so there will be equal attraction between the two. So Mg and O will be attracted towards each other, forming magnesium oxide. Here you go. Great. So This is the way how ionic bonds are formed. Next comes the covalent bonds. Now, as I showed you in the periodic table, that there are atoms on the extreme left hand side and there are non-atoms on the right hand side. When metals, I'm sorry, I think I said atoms. I'm sorry. There are metals on the left hand side and non-metals on the right hand side. When metals combine with non-metals, you get ionic compounds. But we see in our daily life around us a lot of compounds which are not ionic, like water, like chlorine gas, oxygen gas, nitrogen gas. They are not ionic. Like iodine water, iodine liquid, they are not ionic. So what type of combination is there? Now, when you say oxygen, what is the formula of oxygen? O2. So it means it's a combination of O with O, means non-metal with the non-metal. Yeah, that's the point. So when the tendency is such that each combining element needs more than 2 electrons, 2 or more than 2 electrons. So no one obviously will want to lose, because over in the previous case one had a huge a very large number of electrons and a deficiency of 1 or 2, and the other had only 1 or 2 electrons. So a chance was there that one will lose complete electrons to make the other fill its shell completely. But in the case of O2, for example, each oxygen has a deficiency of 2. Over there, deficiency of 2. Now what will happen? Oxygen, none of the atom will try to lose or give its 2 electrons. So what will happen then? Then what will happen? They will come into a contract. Means they will make a joint venture. Means a business, a joint business. That is, each will share equal amount to start the business. That is, each will share equal number of electrons to make a bonding. When bonding is done with a shared pair of electrons, with equal number of sharing of electrons, we call it covalent bonding. And covalent bonding is relatively weak bonding as compared to your ionic bonding. So let's start with the covalent bonding. Now, here is the case. Each atom is sharing equal number of electrons, so that the pair of electrons is common for both the atoms. When you count the 2 outermost electrons, then the pair will be counted in both the sides. So means each will feel that I have complete structure, so both will be happy, because both have acquired the noble gas structure. And that is the beauty of covalent bonding. Here is the case. Say hydrogen gas. What is the formula of hydrogen gas? H2. Great, H2. Now, what happens? Each hydrogen has 1 electron in its outermost shell, and since it is the first shell, so it needs 2 electrons to be filled completely. Now, will any of the hydrogen will lose electron? Obviously no, because it will say, why I will lose 1? Because you have only 1. If I lose 1, why don't you lose? So they will not try to lose, rather they will come up to a mutual contract. What they will do? They will share their electrons, and that's a quite good job. So both the electrons will come up as a pair. We call it a pair of shared electrons. And when the first hydrogen will see its shell filled with 2 electrons, oh, I'm happy, I'm filled. The second hydrogen checks its shell, oh, I have 2 electrons, I am filled, oh great. So means both are happy, bond is formed, and this is called covalent bonding. Bond will remain there as long as the sharing is there. The moment the sharing is lost, bond is lost. Great? Cool. So same is true with the other types of covalent bonding, whether it's between 2 atoms or 3 atoms, whatever be the case. Now, when we represent a covalent bond, we always represent with the help of that dash or a line or a hyphen. If there is a linkage or sharing of 1 electron by each atom, we call it a single covalent bond. But if there is a sharing of 2 electrons by each atom, we call it a double covalent bond. And if there is a sharing of 3 electrons from each side, it is a triple covalent bond. Can any atom share 4 electrons? My question. Means sharing of 4 here and 4 here. Is it possible? Tell me. So normally the maximum bonding for the covalent is 3 electron from here and 3 electron from here to make the outermost shell complete. Let's go further. Hydrogen, same situation I just explained. They both need 1 electron. What they will do? They will come close. Here you go. And they will make a bond. And that bond is called a shared pair linkage, and that becomes a molecule now. Initially, what were they? They were a single atom, hydrogen atom. Now they are become a molecule of a compound called hydrogen gas now. Great. Cool. Now, this is the presentation of hydrogen molecule. Either you write with 2 dots between 2 hydrogen, where each dot will represent 1 shared electron, or a single line representing a single covalent bond. Great. How about the chlorine? Chlorine gas, Cl2, present in group 7. Each chlorine needs 1 electron so that its outermost shall be completed. Now, none of the chlorine atom will give its electron to the other chlorine because both have the same situation. So no one want to lose. So what they will do? Again, they will come close, make a pact, make a sharing of the same number of electrons, and what will happen? See, this is the thing what will happen. Here you go. Now count the number of electrons for 1 chlorine, total 8. Count the number of electrons for the second chlorine, again total 8. Both are happy and the life goes on. So this chlorine molecule now is composed of 1 shared pair of electrons, so it will be a single bond or single covalent bond represented by Cl-Cl. Great. Cool. Now, do we have only single bonds? No, I just said we have double bonds as well, we have triple bond as well. Let's see some other examples in which there is a double or triple bond. Alright. This is again a single bond combination, so I'll explain later. I want to go to the triple bond thingy. So let's go to triple bond. Hold on. Yeah. Double bond, I mean. Say, in case of oxygen, one oxygen want to combine with the other oxygen. What is the barrier? No one want to lose. Obviously, no one want to lose because both are at the same situation. So, what is the best idea? What is the best approach? That is come close. So, each oxygen will combine with the other oxygen by sharing equal number of electrons, which are 2 in this case. So, if 1 electron on the right side will count its number of electrons outermost shell, total 8. The other oxygen on the left hand side will count number of electrons, total 8. So both oxygen are happy because they have their outermost shell filled. So the bond will be formed and an oxygen molecule will be formed, O2. Now how many electrons are being shared? 2 from each side. So it will be a double covalent bond and is represented by 2 lines. Here you can see here. So I think we should stop here for the double bond, and later we'll discuss, say after this session inshallah. See, for that long, Allah Hafiz, bye.